Welcome to your finite math lesson for R.4. We're going to split R.4 into 2 days. So this is day 1, and today we're going to look at linear and quadratic equations, and we're going to solve them. So that's the objective for today. All right, so let's start off by solving the following linear equations. That means you just have plain x's in them. You don't have x squared. You don't have anything strange going on with the x. You're not dividing by x, anything like that. Okay, let's look at problem A. 3 times the quantity 2x plus 25 minus 2 times the quantity x minus 1 equals 78. Now, you need to simplify everything on this left-hand side. Right-hand side is simplified first. Okay, we need to simplify this left-hand side, and then once we get it down to a single x term and a single number term, we'll start talking about what we're going to move from side to side. But the first couple of steps are just going to be simplifying this left-hand side. All right, so let's think about our order of operations. Inside the parentheses are simplified. There's no exponent, so let's do multiplication. So I'm going to distribute the 3, and I'm going to distribute that minus 2. I need to think of that as multiplying negative 2 times the x and the minus 1. All right, so 3 times 2x is 6x, plus 3 times 25 is 75. Negative 2 times x gives us minus 2x. Negative 2 times negative 1 gives us plus 2. Now we still need to keep simplifying by combining like terms over here on the left side. So 6x minus 2x is 4x. 75 plus 2 is 77. And we still have equals 78. Now that we have the left-hand side simplified, we want to start moving things. All of our x terms are on the left, so let's subtract the 77 from both sides, and we get 4x equals 1. Okay, so that's 4 times x equals 1. We're going to divide both sides by 4, and that gives us x equals 1/4. Now, if you want to check your work, you can take that 1/4, plug it into this equation, and make sure you get a true statement. Make sure you end up with 78 equals 78. Remember, that's what a solution means. It means that when you plug it back into the original statement, you end up with something that's true. All right. We've got 4x minus 1 over 4 equals 3x over 4. Since both our x's are on top, that does mean we have a linear equation. You've got one fraction equaling another fraction, so we can cross multiply. So that's what we're going to do. So we're going to do 4 times 3x equals 4 times 4x minus 1. I need to simplify on either side of the equal sign. So 4 times 3x is 12x. 4 distributed across 4x minus 1 gives us 16x minus 4. Okay, we want our x's on one side, so let's subtract 16x from both sides. And we get negative 4x equals negative 4, because this was minus 4. So x is being multiplied by negative 4, so we're going to divide both sides by negative 4. And that's going to give us x equals positive 1, because negative 4 divided by negative 4 is 1. All right, 2/7 x plus 3/5 equals 4/7 x. Well, now there's fractions, which nobody's going to say, oh, fractions are my favorite thing, but they're in here. We can deal with them. If you look, this left-hand side is simplified. You've got an x term and just a constant term. Over here, you just have an x term. So we're ready to start moving things across the equal sign. So we're going to subtract 2/7 x from both sides of the equation. So I'm actually going to write that on the right hand side here. I have 4/7 x minus 2/7 x, just so we can kind of talk through it. On the left hand side, all that remains is 3/5. So let's think. We've got 4/7 x minus 2/7 x. They're like terms. We just subtract the coefficients. So 4/7 minus 2/7 is 2/7. So we've got 2/7 times x left over here on the right-hand side. All right. Now, whenever we have our x multiplied by anything, we divide by that number. So we want to divide by 2/7, but remember, dividing by a fraction is the same thing as multiplying by its, yeah, you're right, it's reciprocal. So we're going to multiply by the reciprocal of 2/7, which is 7/2. So I'm going to have 7/2 times 3/5 equals 7/2 times 2/7 x. Now, On the left, of course, we're going to do the 7 times 3 is 21 over 2 times 5 is 10. On the right, the 7's canceled, the 2's canceled. That's what we wanted. We're just left with x. So x is 21/10. Okay, quadratic equations are ones that can be written in the form ax squared plus bx plus c equals 0. You have to have an x squared. There are a couple of ways to solve. You can factor and set the quadratic equal to 0 and then solve. Actually, I said that kind of backwards. You set the whole thing equal to 0, then factor, then solve. If the quadratic is not factorable, or if you just don't want to mess with it, you still set the equation equal to 0 and find the values of a, b, and c and use the quadratic equation x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so we've got 3 examples here. So let's go ahead. We'll start with 2x squared minus 32 equals 0. We want to factor out a 2, greatest common factor, and that leaves us with the x squared minus 16 equals 0. Well, x squared minus 16 is a difference of 2 squares. And so we're going to factor that as x minus 4 times x plus 4, bringing down the 2 just because, we can't get rid of it, or we haven't gotten rid of it. We could, but we just haven't. So now at this point you set each factor equal to 0. So 2 equals 0. Well, we can go ahead and put a little line through that because 2 can't equal 0. Anytime you have a number other than 0 equaling 0, you can just kind of ignore that. It's not going to give you a solution. X minus 4 equals 0, x plus 4 equals 0. So we get x equals 4, x equals negative 4 as our 2 solutions. Okay, so 2 solutions there. All right, our next one is x squared plus 6x minus 16 equals 0. So let's see, AC is negative 16, and we need numbers that add to be 8. So add to be 6, not add to be 8. I was already thinking about the number. Okay, sorry about that. Numbers that multiply to be negative 16, add to be 6 are 8 and negative 2. So x plus 8 times x times... Okay. X plus 8 times x minus 2 equals 0. And so we're going to set each one of those factors equal to 0. So we have x plus 8 equals 0, x minus 2 equals 0. So x equals negative 8, x equals 2. All right, last one, we've got 2x squared plus 5x equals negative 1. Remember, anytime you're solving a quadratic, the first thing you want to do is get the whole thing equal to 0. So I'm going to add the 1 to the right-hand side, the left-hand side, actually, and the right-hand side. When I add it to the right-hand side, negative 1 plus 1 is 0, and then we see our plus 1 over here on the left. You can try to factor that. You can try the AC method all day long. It's just not going to work. So we're going to use the quadratic formula. So A is 2, B is 5, C is 1. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And so let's plug in our values. So x equals negative 5 plus or minus the square root of, and make sure you put whatever you're squaring in parentheses so that you don't make a mistake if you're entering it into your calculator and you have a negative base. Let's just always get in the habit of whatever b is, we're going to put in parentheses. So put parentheses around the 5 squared minus 4 times 2 times 1 over 2 times 2. So let's see, 5 squared is 25. 4 times 2 times 1 is 8. So we've got negative 5 plus or minus the square root of 25 minus 8 over 4. 25 minus 8 is 17. X equals negative 5 plus or minus square root of 17 over 4. Now notice up here it says if the solutions involve square roots, give both the exact solutions. That's what we've got. We actually have 2 solutions there. Negative 5 plus square root of 17 over 4. Negative 5 minus square root of 17 over 4. And the approximate solutions to 3 decimal places. So you want to take your handy dandy calculator and do negative 5 minus square root of 17 over 4. Negative 5 plus square root of 17 over 4. And we get approximately negative 0.2129, negative 0.219, and x is approximately 2.281. Okay, so we've got our 2 solutions written in exact form and then also in approximate decimal form, rounded to 3 decimal places. Okay, guys, try the problems to try on your own. If you can do them, that's great. If not, go back and review some of the video or come in and get help from me because you want full credit on your notes. So make sure you try those problems to try on your own. All right, good job taking your notes. I will see you in class. Have a good day.